welcome all to another session of Concept at Fingertips. This is Vidya, Physics faculty. Today we are going to learn the topic magnetic field and magnetic field lines from the chapter Magnetic Effects of Electric Current. So what is meant by magnetic field? Magnetic field is the space around a magnet. Space around a magnet where its effects can be experienced. For example, as we have already seen that if some iron filings are placed around a magnet, they get attracted. So they get attracted to the poles. And if another pole of a magnet, if a pole of another magnet is brought near this particular magnet, then they will either get attracted or repel depending on like or unlike poles. So the space around, it is the space around the magnet where these magnetic effects can be experienced. That is meant by magnetic field. So what are magnetic field lines? Let us see. So magnetic field lines are basically imaginary lines. So they are imaginary lines around a magnet. So these lines are actually the lines where the tangent at any point on this line, at any point on these lines, we draw a tangent and that will give the direction of magnetic field. For example, we have a bar magnet here and there are some lines drawn around it, and these lines are the magnetic field lines. And as we already said, they are imaginary lines, and at any point on these lines, if we draw a tangent, for example, if I draw a tangent at this point on that line, then it will actually show the direction of magnetic field. So that is the direction of magnetic field. So how can we experience the magnetic field lines? One way to experience is that if we spread some iron filings around a magnet, then these iron filings actually get aligned in the direction of this in a pattern such a way that it shows the magnetic field lines. Again, another way we can use, another method we can use to find the magnetic field lines is like if you keep a magnetic compass, if you keep a compass needle by using a compass needle, that is another method. So if you place a compass needle anywhere around the magnetic field, anywhere in the magnetic field, then the compass needle get aligned in such a way that the north of the needle will point the direction of magnetic field. So if you place a magnetic compass here, right here, then it will be like the north of that needle will point like that and like that. And if you can continuously keep the needle, then we can find out the direction of we can find out the line draw the line continuously. So these magnetic field lines have some important properties. Let us see the properties of magnetic field lines. So now we are going to see the properties. Properties of magnetic field lines. So first property that we can see is that all these lines are closed curves. So these magnetic field lines are closed curves, and they come out of the North Pole. So out of the magnet, outside the magnet, we can see that these lines comes out of a North Pole, and they go inside to the South Pole. So that can be seen in this picture also. From this picture, we can see that from the North Pole, they starts and then they ends. They kind of go into the magnet in the South Pole. And another important thing is we saw that it is closed curve. So they continue inside the magnet also. These lines go into the South Pole and they continue inside the magnet as well. So these are the first important, this is the first important property, that is they are closed curves. They are imaginary lines and they are closed curves. So let us see the second property. So the relative strength of magnetic field is shown by degree of closeness of magnetic field lines. So as we can already see here, at the poles, we know that the strength of the magnet is maximum at their poles. So near the poles, if you see, we can see that the lines are closely placed together. And when you go away from the magnet, just like that at the middle point and all, the lines are getting placed not very close to each other. So they are farther apart from each other. So when they are close together, we can see that the magnetic field is maximum, or magnetic field strength is maximum. And when they are farther apart in distance, then we can see that they are the magnetic field is less strong. And from this figure, we can see another important feature, that the distance between these lines are getting farther away. Like distance between these lines are increasing as we go away from the magnet. Another important property of a magnetic field line is that the magnetic field lines never get intersect each other. So that is the next property. Two field lines never intersect each other. So this can be explained in another way. Like if you take a compass needle and if you take a compass and place at a point, the compass north of the compass should point the direction of the magnetic field. So if the two lines are intersecting, for example, if at a point, if the two lines are intersecting and we are keeping the compass needle at that point, the compass needle must point to two directions now. So which is impossible. So two field lines will never intersect each other. Again, if the magnetic field lines are placed in uniform distance between them, if they are placed uniformly, it means it implies a uniform field. Uniform field means the value of the magnetic field is same in that region. For example, if we have parallel lines, the field representing in that way in parallel lines with the distance, same distance between these lines, then we can say the field is uniform magnetic field. I hope the topic is clear to you. We'll meet you in another session with a new topic. Thank you.